Today we are covering 12.2 surface area of pyramids and cones. You guys are going to be able to find the surface area of these two shapes. So our vocab here, pyramid. This is a solid with one polygon base and the rest of the faces are triangles. We have slant height. The height of the triangle is the pyramid. This is different than the height or altitude of the pyramid. We have to use Pythagorean theorem to get this, unless it's given to you. And then we have the cone, solid with a circle base that comes to a point at the other end. So we have the lateral area of a regular pyramid. The lateral area L of a regular pyramid is L equals 1/2 the perimeter times the slant height. So it says where L is the slant height and P is the perimeter of the base. So this is something I would add to that cover page. You need to find the slant height because that will be the height of the individual pyramids triangles. So if you notice here, we are basically finding the area of each of these triangles, okay? And reminder, once again, this is lateral area, so that's just the area of the triangles. It does not include the area of the base. This area is not included in this formula. So we're gonna just use our formula. Our lateral area equals 1/2 the perimeter times the slant height. So it goes from the side of your base to the tip at the top at a perpendicular. That's our slant height. In this case, they gave it to us. It is 5. Our perimeter is 2.5 times 4, because there are 4 sides of that base, or 10. Otherwise, you can just take 2.5 and add that 4 times. That will also give you the perimeter of 10. And then we multiply that by 1/2. Once you plug this into your calculator, you get that your lateral area is 25, and it's in centimeters, so square centimeters. All right, we've got a U try. Go ahead and try it. Same formula, guys. We have our lateral area equals 1/2 our perimeter times our slant height. And this gives us a base side and our slant height. We have to find our perimeter again. We can just take 4 plus 4 plus 4 plus 4. That is 16. Our slant height is 8. We multiply that times 1/2, and our lateral area is 64. So 64 square inches is our answer. Now, if we move on to finding the actual surface area, it's a very similar equation. We have our lateral area equation here, but then we add the area of the base to it. So whatever the base is, you add that area. Now, if you notice on this first equation, you are not given the slant height. We are going to have to find it using Pythagorean theorem, okay? This is technically the altitude because it's dropping down to the center at 90 degrees. So we have, we have a right triangle here. This is 6, this is 4. We need to find our slant height, L. So let's do the Pythagorean theorem. 4 squared plus 6 squared equals L squared. So we have 16 plus 36 equals L squared. 52 equals L squared. We square root that, and L is about 7.2. That is our slant height. We need that for our lateral area here. So let me highlight these. This is our slant height. We can also find our perimeter. So the base's sides are 8, 8, 8, and 8. So you can either add those or take 8 times 4. Either way, that is 32 for our perimeter. And we have our slant height, so we can go ahead and start finding our surface area. 1/2 the perimeter times our slant height. And then we have to add the area of the base. Remember, for a square or rectangle, it is just base times height, or length times width, whatever you want to say. So the big B area of our base is just 8 times 8, or 64. So we plug that in here. Guys, all I'm using is this formula. I do the multiplication on the left side of the equation, and then I add to that the 64, and I get my final total surface area. So this does include the area of the base this time. Okay, this question is a little more tricky because we have a hexagon as our base, which means we're going to have to go back to last chapter. Thankfully, the lateral area is really easy because they do give us the slant height, so we don't have to do that step. So let's start out by just doing the lateral area. We have 1/2 times our perimeter. Guys, our perimeter is going to be 10.4 times 6 because there are 6 sides. This gives us 62.4. Our lateral area is 15, so let's plug that in. Now, when we add our big B base to this, our base is this hexagon, which is a regular n-gon, which we learned last chapter was 1/2 the perimeter times the apothem. So we're lucky. We just found the perimeter. We just found it right here. It is 62.4. We don't know the apothem though. That's problematic. So we now have to break this hexagon down and try to find this side here. So I'm going to redraw my hexagon as best as I can. I'm not a great artist. And then draw in what I need to find, the apothem. Now, if you recall, we make this into some triangles, but then we only use half of it right here. We are trying to find the apothem. So things we know. We know this whole thing is 10.4. We need half of that. That is 5.2. We know this whole angle is 360 divided by 6 is 60 degrees, which means we need half of that for here, 30 degrees. Now we can do trig. And yes, guys, I'm going quickly through this because we've already learned this, okay? We have our opposite and our adjacent based on this perspective angle. So we're going to do tangent of our degree is equal to opposite over adjacent. I then have to get A by itself, which means I take a little bit of a roundabout way. I have to multiply by A on both sides. The A's on the right cancel out. I'm going to go ahead and rewrite this. And then I divide by tangent 30. And then tangent 30 on the left side cancels out. And once I plug this into my calculator, I get that A is equal to 9. So our apothem is 9 centimeters, which means I can plug that into my formula up here. Let me highlight these again. Okay, I also can plug in my perimeter, which I found for the other part of the equation as well. So I'm going to solve this part here. All I have to do is plug it into my calculator. It gives me 468. And then I'll plug in this information. So we have 1/2 our perimeter times our apothem, because that is the base formula for a hexagon. This, when I plug it into my calculator, gives us 280.8. I add 468 to it. I get 748.8 square centimeters for my surface area. And it did ask me to round to the 10th, which is 1 decimal place, so I did. Alright, you guys go ahead and try the U-try. It's like what we just did, and I'll pop the answer up there in a second. Alright guys, so this is my formula here, where I am having to find our surface area. So I had to find my perimeter, which was not too tricky. I just had to take 6 times 6 because there are 6 sides and each side is 6 inches apiece. And then my slant height was given to me, and then I had to do my trickier work where I had to find the apothem. So once again, I wrote my hexagon down here, I split it out into my right triangle, and then I used trig to find that apothem. I did skip a couple steps here. If you're confused, just reference back to our last problem. I did those exact same steps there. Then, all I have to do is plug in my perimeter, my slant height, my apothem in my perimeter again, use my calculator, and I will get my solution. Alright, let's move on. So we have to find the lateral area and surface area of a cone. So we have both of our our problems, our examples here. Equations, that's what I'm trying to say. Our lateral area is our pi times radius times slant height. Notice that it's not the apothem, it's not the perpendicular height, it is the height on the side. And then for our surface area, you just take your lateral area and then you add the area of a circle to it. So, we have a conical birthday hat has an altitude of 6 inches and a diameter of 4 inches. Find the area of the birthday hat. Okay, that's a problem. They don't give us our easy information. They give us our altitude, which is this height, and they give us our diameter, which is this length. So they told us this was 4, and this is 6. We need to find our slant height. To do that, we are going to just use this right triangle, but we don't want to use 4 down here. We want to use 2, because the radius is half of the diameter. And now we're just going to do Pythagorean theorem. So we have 2 squared plus 6 squared equals L squared. So we have 36 plus 4, or I guess in my case 4 plus 36 equals L squared. So 40 is L squared. Take the square root, and 6.3 is L, our slant height. And since we are just finding the lateral area, we only use our first formula. Lateral area is equal to pi times radius, which we decided is 2, times our slant height, which we decided is 6.3. Plug that into our calculator, and we get 39.7 square inches, or A. Alright, now we're going to find the surface area of our cone. Our surface area formula is pi times radius times slant height plus pi times radius squared. Hey guys, lucky for us this time they gave us our radius and they gave us our slant height, so we don't have to do any extra math. All we have to do is easy peasy plug this stuff in. Okay, we do this in our calculator. The first part gives us 14.07. We are going to end up rounding to the nearest tenth, but sometimes it's easier to keep more decimal places so your rounding is not off, especially in Delta. It can be a kind of picky. So anyway, you add these together, and then I did round to the nearest tenth. So we have 20.2 square centimeters. All right, go ahead and try the U-try. Okay, hopefully that wasn't too difficult because once again, this gives you the slant height and the radius. So all you do is plug this into your formula. So our radius is 3. Our slant height is 4.5. Use your calculator. Once again, I'm keeping a lot of decimal places. And then I'll round at the end. We get 70.7 square centimeters, or D, for your solution. So the cone ones are fairly simple as long as they give you your slant height and your radius. If not, you might have to do trig, you might have to do Pythagorean theorem. We saw Pythagorean theorem just a second ago. All right, guys, this is a table with all of the formulas that we've learned so far. These are things that I would add to your cover paper. I'm also going to write some things down here to help you out in remembering like what the letters mean. So, P is perimeter. H is height, specifically the perpendicular height. It has to be at 90 degrees. Big B is the area of your base. Now that changes out. Like this one, the base is a pentagon. This one is a rectangle. Okay, make sure you're switching them out for the correct base area formula. Capital L is your lateral area. Lowercase l is your slant height. And R is your radius. All right, hopefully that helps you guys out. If there is extra time, you guys can go ahead and pull up Google Classroom and work on the worksheet that's on there. Or if you haven't finished your delta from 12.1, you can do that now. Bye.